Bismillah. Okay, good morning class. So this will be a bit, the lesson will be a bit shorter today because you guys have written a test. The test will be marked tomorrow during our maths period, inshallah. You get one? Nice. Okay. So at this point we are busy with your congruency. Not congruency namely, but similarity that we started off with. Okay. So let's go. So I gave you two sums for homework yesterday. Not yesterday, but in the previous lesson. So you had a lekker day off yesterday. Hope you enjoyed it. And I gave you number 3 from an exam paper at the end of the book, which is on page 208. I'm going to do both for you. And then we'll start with our congruency today as well. Okay. So looking at this here, it says prove that triangle PQR is similar to triangle RSQ. So if you look at what is in question here, it's going to be Q PR, which is that one there, and R is Q. So is that triangle there. So what can we say about, okay, firstly, how do we start this off? We say in triangle PQR and triangle RSQ. What can I say? For similarity, what do? We prove 3 angles are equal, not so?
Yes, sir.
So now which angles are equal here? Angle R1 and angle R, yes, which is 90, and P. So I say angle P is equal to, can I just say angle R? Safer for you not to. Just say Q R S or SQR is the same. And then it's equal to 90. Why is that 90? It was given to us. Not so? Right. What else can we say about that? Is another angle that's equal to each other of the two triangles. Q1, yes? Is equal to? You see this here is marked with 2 arcs there. If you see something like that, that means to say the angles are equal. It's given equal. You guys understand?
Yes.
So 2 arcs, they're given equal. Or if I had 1 arc there, equal. Or 3 arcs, also equal. Okay. So in a diagram, if that is given, you should know it's equal. So you say Q1 is equal to angle R1. Why? It was given. So which angle are we left with in the two triangles? In triangle PQR, in this triangle, what are we left with? Which angle? We spoke about P, we spoke about R1. Q. Can I just say Q? No. It's going to be P, Q, R is equal to. In the other triangle, I've accounted for Q1. I spoke about angle SRQ. So which angle are we still to note? Angle S. So that angle is equal to angle S. And what's my reason here? Third angle of triangle. If 2 angles are equal in a triangle, the third one's automatically equal. Is that enough to conclude similarity?
Yes.
Absolutely. So therefore, triangle PQR is similar, and most of the time the order is correct. So it's going to be P, Q, R. So it has to be R. SQ is absolutely correct. Okay. The reason why they give you that in the right order is so that you can apply it on the length question next. You guys understand? Alright, so it's similar to triangle RSQ. And on what account is that? Angle, angle, angle. Not so? And what did I say? Most of the time, a distance question will follow that. Not so? So let's check. Angle, they ask you to calculate F, and you see where F is. is F. Not so? Can you use Pythagoras? Well, what do we need for Pythagoras? A right angle triangle. Do we have a right angle triangle? Yes. Do we have two lengths? Yes. From this triangle, we got 50. Where's the other one? F is unknown. That's what we're going to calculate.
Oh, the QR.
We don't have QS. So we're going to go with the ratios of this here. So just take this off here. I don't want to move away from the diagram. I have some separation issues here. Right, so what do we say? What do we say, people? We say PQ over RS equal QR over SQ equals SQ it's the same thing. SQ and PR over RQ. And the reason there is going to be that triangle PQR is similar to triangle RSQ. Now, in the exam, say for argument's sake you didn't manage to prove that those two triangles are similar. In B, you can use the fact that they are similar. So if you didn't manage to solve that thing, use that as I just did now to get ratios out. Okay. Otherwise you're going to lose 4 marks and again 4 marks or 3 marks. Okay. And again, that is the reason why the order is given, so that you can, for those of you who can't prove that, you can apply it in the next time. So PQ is equal to what? PQ is 9 over RS F equals QR 15 over SQ unknown equals PR. PR is also unknown over RQ, which is 15. So what do you notice? I don't have a known ratio. Not so. So going back to the diagram. If we can inspect in the other diagram, in the other triangle, what do you notice? There can actually apply the theorem of Pythagoras. Not so? So let's do this on the side. We say in triangle PRQ. We have a triangle looking like this here. So it's QRP 915. I'm going to calculate PR. Why? So that I can replace PR here. In turn, I will get my known ratio that I want to work. Can you see that, people? So, can somebody set up the theorem of Pythagoras from here? It's going to be what? QR squared is equal to? QP squared plus? PR squared. Or we can say straight, 15 squared is equal to? 9 squared plus? PR squared. And what's my reason there? The Pythagoras theorem, Pythagorean theorem, with angle P equals 90 degrees. People, don't forget to write this here. If you're not going to write it, you are going to lose a mark. Right, are you all okay with that? Right. So 15 squared, 225. What is 9 squared? Take it over, becomes minus 81 is equal to PR squared. So 225 minus 81 gives you 4144. So PR squared is equal to 144. What's the square root of 144? 12. 12 centimeters, or 12 units, whatever. So you all agree that this now can be replaced with 12 now. And there I have a known ratio there. Can you see that, people? So what do we have? 9 over f is equal to 12 over 15. So what do I do now? Cross multiply. So 9 times 15 is a fairly large number, is equal to 12 times f is 12f. Divided by 12 both sides. Therefore f is equal to. So 3 goes into 9 3 times, 3 goes into 12 4 times. Not so? What's 3 times 15? 45. So it's 45 over 4. Or that goes 11, comma 25. Yeah, 11, comma 2. Okay. People, this is now the fourth sum we're doing, the fourth or fifth sum we're doing on this. Okay?
Yes, sir.
So, if you have a problem with this stuff, redo the sum a few times. Okay? You will get it right. If you're stuck again, refer back to the video. You should be able to get this right. Okay? It is, however, coming in your upcoming exam as well. No? So please don't waste your time. Alright, let's do the last one quickly before we go into congruency. Now, in the middle of a lesson. Okay. Right, so for 3.3 we are told in the diagram ADE is equal to angle B. Can you see here? That's given on the diagram and given in the introduction to the sum as well. Not so? So we are told that prove triangle ADE is similar to triangle ABC. Don't do this during a lesson. We do it at the beginning or at the end of the lesson. Okay. So, if you look at the triangle, it's ADE and ABC. Where do we start? We start by saying in triangle ADE and triangle ABC. What can we say? Sorry? Angle A is in both triangles, not so? So what do we say that for that? We say that angle A is a common angle. Since it's in both triangles, it's a common angle. What else can we say? ADE is equal to angle B. As you can see, that was given to us. Okay? Yes, so that is in this triangle we have accounted for A, we've accounted for B. So C is what we're left with. In the other triangle we have accounted for D, we accounted for A, then it's going to be E that's left. Not so? So what do I say? Angle C is equal to DEA. Why? Is that given to us? No? The third angle in triangle. So is that enough to conclude similarity? Yes, absolutely. So therefore, triangle ADE is similar to triangle ABC. On what account? Angle, angle, angle. Did I say angle, angle, angle earlier? Yes, okay. So, yes. For similarity on this level, yes. Okay. Later on in grade 12, it will be size and proportion as well. It can be one of the two. But that we only do later on in grade 12. If you make it with maths. No? If you want to drop maths. But don't drop maths. Maths is beautiful. Right, so the next question says in 3.3.2, if AD is 30, and BD is 50, DE is 24, and BC is under. So what did I say? Majority of the time, you will have a distance question following a similarity question. Not so? So it's going to be AD over AB equals DE BC equals AE over AC. Why? Because triangle ADE is similar to triangle ABC. Okay? So what's the length of AD? 30 over AB. Now AB is this whole length here, which is 80 equals BE DE over BC. Then that's what I want to calculate. Not so. BC is what I want to calculate. And then we go AE. It remains AE over AC, which I don't have. But this is what I'm interested in. So I can cross multiply, not so. So it's going to be 30. BC is equal to 24 times 80. So you see that number is fairly large. So what I do is I don't multiply it out yet, I first simplify. I divide by 30 both sides. So therefore BC, so 10 goes into 80 8 times, 10 goes into 30 3 times. Not so? 3 goes into 3 once, 3 goes into 24, 8 times. What's 8 times 8? So it's going to equal 64 millimeters, because the units are given in millimeters. Do you guys understand? And you see there's 6 marks for this. 4 marks on 3.3.1, and I would have given you 3 marks in the next one, but they gave you only 2 in the next one. Okay, now not in the exam. When you see it's only 6, then you say, no, I'm not going to do it, it's not worth it. No? Do it. Alright, that brings us to the next section, which is congruency. So your subheading is going to be congruency. The girls that's talking in the background, stop it please, man, no? If you don't mind. These things you do at the beginning of the lesson or after the lesson, okay? Right, so I want you guys to write a little note here for congruency. You see the different sign now for congruency. Similarity was the 3 lines down. Congruency is like equal signs with an extra line, okay? Did you write the conditions for congruency? We will read through them now. Sounds like you guys are finished. So why are you making a noise? Okay, so we are told that congruency, as I indicated, the mathematical notation for congruency is the three lines going across them. Congruent triangles fits exactly on top of one another, which means to say they are the same size and the same shape. Not so? So they can fit exactly onto one another. That means that two triangles have exactly the same. That's exactly what they say. Okay, so it will have they will have the two triangles will have the same size and the same shape. Okay. To prove two triangles are congruent, we need to prove that the sides and angles of the two triangles are equal in certain combinations. It has to be in a certain combination. Where similarity was straight, you can use angles only. However, similar triangles are not necessarily congruent triangles. Not so? Why? Because you can have a big triangle and a smaller triangle with exactly the same angles. They are similar, but they are not congruent. However, every congruent triangle has what's the names? The condition for similarity. Not so? Yes. Why? Because if all the angles are equal, then they are similar. But for congruency, all the angles and all the sides must also be equal. So we see the combinations for congruency, the conditions we call it. The first one is side, side, side. Is when we're proving that three sides are equal. Okay. Then side, angle, side. This one here, let's just put the asterisk next to it. Side, angle, side. If you have two lengths, if two lengths are known and you're using this case for congruency, it has to be, if I got those two sides, it can only be that angle that is equal. Okay? To the other triangle. You understand? So you got another triangle there, we got that thing, then those two triangles are congruent. Why? Side, angle, side. You guys understand? You can't prove congruency if that and that is equal with this length or that. That you can't prove congruency there using this condition. It has to be two sides and an included angle, which means to say the angle that is known is lying between the two known sides. Make sense, people? The two angles, the two sides that we know, the angle is lying between the two known sides. Do you understand, people? That's why it says side, included angle, side. Two sides and an included angle. So that is side, angle, side. Let's take you one back when it asked it showed you here side, angle, side. This could be an example of side, angle, side. You see here? We got two triangles with the same, with the three known sides. Okay, that's also congruent. So let's look at the next one. Angle, angle, side. We have two angles. We have this angle and that angle and a side. Now it can be any side. If we have two angles and any side, that works for us. Provided that the side is opposite, it's the correct angle. So can the known side be here? No. It has to be opposite the angle marked X. Can you see that, people? So it won't work if that known is there. That won't work. Or if it's here, that also won't work. It has to be opposite the correct corresponding angle. Make sense, people?
Yes, sir.
So we got two angles and a side. Okay? Angle, angle, side, and any side. And RH is, the R stands for right hand for the 90 degrees. You got 90 degrees. 90 degrees. So here you got 90 degrees. And the H is what? Hypotenuse. Which is this here, if you know that side and that side. And S is another side. So that two triangles are congruent. Or this could lie here as well. Then it would have been congruent. You understand, people? But if you look at if we look at this here, if I didn't use the hypotenuse, I said okay. You use angle, you use that side. Will these two triangles be congruent? Yes. Why? Which case of congruency are we using here? RHS? Are we using this case for congruency here? No. Are we using the hypotenuse? No. But what do we have? We have a side, angle, side. So which case of congruency is this? Side, angle, side. Make sense, people? So these congruency conditions is very important, people. Okay? Remember, when they ask you to prove something is congruent, we prove one of these four. Okay? And what are the four? Side, side, side. Side, angle, side. Angle, angle, side. And RHS, which is the right hand hypotenuse side. Okay? So let's carry on with our lives. Okay, so very important. Yes, the note you're going to read through, and this is on the next page, which is 147. Okay, so here we are told on page 147. Here we are told that the proof of congruency as a very definite pattern. Okay? It's important to note, according to one of the conditions for congruency, 3 pairs of angles or sides are used in the proof with reason. Following the proof, the remaining 3 pairs of angles and sides may be assumed to be equal. So which means to say, if you prove that triangle ABC is congruent to triangle PQR. Let's check if the order is right now. B corresponds with Q, C corresponds with P, so it's going to be R. And what case of congruency we said this was? Side, angle, side. Yeah? So from here we know that AB is equal to RQ. AB is equal to R2. But that we know already. Then we know that BC is equal to QP. BC is equal to QP. But that we also know already. And we can conclude that AC is equal to RP. AC is equal to RP. Can you see that? So from here we can conclude, therefore AC is equal to RP. What else can we say? We can say that angle A is equal to angle R. You see why order is important here. Angle A is equal to angle R. Right? Angle A is equal to angle R. What else can we conclude? That angle B is equal to angle Q, but that we know what it is, 90. And we know that angle C is equal to angle P. Can you see that? Angle C is equal to angle. So once you conclude that the two triangles are congruent, all the other sides, all of the other 3 sides, and all of the other 3 angles, remaining 3 angles are equal. You understand? Right. People, this is a very, very important concept to understand. In geometry, we're going to use it extensively. Alright. So then the following pairs are right. The order of the names of the okay. Now this year, they were telling you the order is important. Why? So that you can conclude what I just showed you now in green. Right? That the corresponding angles and the corresponding sides are equal. Okay. So let's look carefully at the following examples. Okay. I think we'll probably only get through one now before the bell rings. So for homework, I would like you guys to re-answer the test that you guys have written, okay? Okay, I'm going to look at this here. We're looking at exercise 2 on page 148. Exercise 2 on page 148. Okay, let's look at this quickly. Now, the first few sums are fairly simple. Okay? You can probably have answered these questions without doing what I'm doing here. However, now, this process we're going to do now is of importance for tomorrow's lesson. Okay.
Jamaica Swatboy and Suyama Non Kutuane, can you please report to the office? Jamaica Swatboy and Suyama Non Kutuane, please report to the office. Thank you.
So, what we need to do is we need to prove that the two triangles are congruent. Okay. So, we make up the order. So, we say in triangle ABC and triangle YZX. What can we say? As in similarity, we start with in triangle, same story.
Yes, sir.
Right, so what do we say? AB is equal to YZ. Why? Given. Angle B is equal to angle Z. Why? It was also given to us. ZX. BC is equal to angle B is equal to angle Z. I was about to say. BC is equal to ZX, so it's XZ. Why? Given. Can you see that, people? So what am I using? Side, angle, side. So therefore, triangle ABC is congruent to triangle YZX. Why? So it's side, angle, side. And that's all you do. You understand? For homework, I would like you guys to do. Listen. It's exercise 2. Exercise 2, there are 10 sums I want you guys to do. I think it's fairly simple, no? Enjoy the rest of your day, people. Good morning, class. So on page 148, yes. Salam. Adi? Yes. Adi? How many on?
One.
Thank you. Thank you. 8, 9. The exercise. Thank you. Alright.